The camera has been used as an extension of the human eye from the time of its creation to the present. Man, always looking for ways to expand his view, has flown cameras into the sky on kites, pigeons, and balloons. One of the first uses of aircraft was as a camera platform. Aerial photography has evolved through the years along with our vehicles of aerial transportation. Forward-thinking people saw the value of the synoptic view from space. First came weather satellites. Equipment was developed and improved as we gained more experience in the field of remote imaging of the Earth. Then Apollo, and later Skylab missions gave us opportunities to test new theories and equipment. NASA's U-2s and RB-57s were pressed into service to further our knowledge and test equipment for future space applications. In 1972, we were ready. That summer in California, NASA and contractor crews prepared for the launch of the first Earth Resources Technology satellite, the ERTS-1, now called Landsat-1. It was based on the Nimbus weather satellite configuration developed by General Electric of Valley Forge, Pennsylvania. The checkout complete, Landsat-1 stood ready on its Delta booster. Technicians make final checks on the health of the spacecraft, its multispectral scanner and return beam Vidicon systems. Tension grew as the clock ticked away the minutes of the final countdown. 2:06 Eastern Standard Time, July 23rd, 1972. The years of design and preparation were now to be tested in the flaming roar of rockets as this Delta booster pushed its payload into an Earth orbit. Landsat-1 was just the beginning. For 15 years, a series of Landsat spacecraft have been recording pictures of the Earth's surface. Launched into polar orbits, the Landsats cover the complete Earth's surface every 18 days. The spacecraft's cameras send their data back electronically as a binary code of numbers which ground stations decipher and manipulate, changing them into photographic images suited for the particular need of the user. Pictures of the Earth's surface from Landsat-1 and later from Landsats 2 and 3, launched in 1975 and 1978, gave scientists in many disciplines new opportunities to understand the complex systems of the Earth. Each Landsat picture covers an area of about 110 miles by 110 miles. This one picture would take 100 aerial photographs and months to assemble and analyze. The Landsat data takes just days. Since Landsat-1's launch, more than 130 countries have used its data to study and understand their resources and environment. In 1982, a new Landsat configuration was put aloft, Landsat 4. In addition to the optical scanning system carried by the first three Landsats, this spacecraft carried a new scanner, the thematic mapper, for high-resolution studies. The square segments of scan lines looked at by the first Landsats doubled in size. Its thematic mapper also increased the number of spectral bands of light measured in each segment from 4 to 7. A single scene from the thematic mapper of Landsat 4 contains 6 times more data than a similar-sized area from the first Landsats. We have only an idea of what the long-term future holds for Earth system sciences. We know it's going to keep improving as we continue to learn and apply new and developing technologies. An example is this computer-generated trip around Los Angeles. Created from a single Landsat photo by the Jet Propulsion Laboratory's Digital Image Animation and Multi-Mission Image Processing Laboratories, this single picture, taken from an altitude of about 500 miles, was combined with elevation data and manipulated for 5 days and 11 hours on a mainframe computer. The process used 2.6 billion bytes, or the equivalent of 2.6 billion words of data, to create this visual display. We're doing this today. What might tomorrow bring? Our ventures into space have taught us much about our planet Earth. We have come to understand its uniqueness in our solar system. We have come to realize better the importance of its fragile ecosystem. Now we, all of us who live on this planet, must use our best science and technology in order to protect and utilize our island home in a way that will assure her life-giving substances for future generations.